This is a penis bone, also known as a baculum or a bacula. What animal do you think this penis bone is from? This baculum or bacula, which is Latin for staff or stick, is present in a lot of different mammal species. Again, it is a penile bone. This baculum is from the largest one that exists in the animal kingdom, which is from the walrus. This baculum actually had something go wrong with it. Bones throughout their lifetime, we can break them, shatter them, but they can grow and be repaired, and that happens throughout life. That's called bone remodeling. You know someone or you yourself have gotten a broken bone, and we know we have to go seek medical attention, and then they set it, make sure it's aligned properly. Sometimes they have to fix it with surgery, but they want to make sure that the shafts of the bone are properly aligned so that they do not grow back incorrectly. Because as soon as a bone is broken, your body will begin to heal it. Most of us had probably heard of a bone having to be rebroken or reset, and that's because it was healing itself, but it was misaligned. So here we have an example of a baculum, but there's something wrong with it right here. This is an example of a baculum that has been broken and then remodeled. So while the animal is still alive, its body healed the area. And it kind of highlights part of the healing process. You can see that the bone is larger in this area, and that's because when a bone breaks, the blood cells go to that area and then it begins to repair. And it does this by forming a bony callus around that injury point. You can see here was that injury point, and then the bone started to fuse back together. So this was a significant injury that the animal lived through. That is our first bone we're going to talk about. In this collection of skulls I have in front of me, we're going to highlight when things go wrong, basically. So one example is from this result of a trauma, so a physical wound or injury, and the other could be the result of a pathology. Pathology is the study of diseases. So that includes the cause of a disease, the consequence of a disease, like how it affects an animal or a person, and then also that does include possible treatment options. So here we have the walrus baculum that has a traumatic wound or injury where the bone has been broken, but then remodeled and fused back together. Here we have an undamaged baculum from a smaller species, a small omnivore that most of us have probably seen in our own neighborhoods. This is the baculum from a raccoon. This is a baculum from a raccoon that has been damaged and has been remodeled. So it also looks like it could have some evidence of a pathology, like an infection, but you can see it's definitely a little bit different from the one without a pathology, but the animal did survive the injury or the pathology and lived. And you can tell because those bones, again, have fused back together. I have a few more examples here that I wanted to go over. One you probably recognize just based on the teeth. This is the skull of a beaver. Now, beavers are known by their characteristic front teeth. These rodents are very large, and they have a special adaptation where their front teeth, their front incisors is what they're called, they grow throughout their lifetime. So beaver teeth grow about 1 millimeter every single day. They grow 10 times faster than human fingernails. So they are growing because rodents are constantly gnawing on things. Of course, beavers make their homes from trees and they're herbivores. So they're constantly wearing these front teeth down. So they have this special adaptation that makes their teeth grow fast. And also they have this orange color on the outside. Most of the time people think that this is due to the wood that they're eating. This actually comes from internal. It's inside of their own bodies. This is an outer layer of iron salts that coat their enamel, and it actually keeps the outside of their teeth really strong and reinforced. Now I'm going to flip the skull over. One special feature about this particular skull is the outside of the bone has been cut away, so you can actually see the inner teeth exposed. So I'm going to turn the skull around so you can see how far a beaver's teeth are actually rooted inside of their skull, and it's amazing. So look how long their central incisors are. Look how far they go into the jaw. So this is a really special adaptation of rodents. So we can see the back teeth are very flat and wide. They're molars. That's a characteristic of herbivores, but their front teeth are these ever-growing incisors. Again, that's an adaptation. But Now, what does this have to do with pathology? So what I wanted to show you is sometimes these teeth can actually grow back up into the skull, and that's called malocclusion. Basically, malocclusion would be a misalignment or a bad alignment of the teeth, which can happen if the animal is injured in some way, has a problem like a dental issue, or maybe doesn't have access to the types of foods that they need to gnaw on. So what happens is these front teeth, they can actually continue to grow, but actually grow back up into the animal's skull. And we have a few examples of that in the museum with these malocclusions. So that's what we most commonly see affecting our rodents. The woodchucks that we have in the museum are a few examples of that, and those are on display in our rodents exhibit. But what I wanted to show you here is an example of a traumatic wound or injury that the animal actually survived through. So what do you think that defect is there? What could that possibly be? You can see what it looks like when the animal's healthy and undamaged. What do you think that is? If you guessed a bullet or a pellet from a bullet, that is correct. So this is actually a pellet from a bullet that is embedded into the animal's skull. And unfortunately, we have seen several examples of this in the education department. These skulls come to us, often are donated to us. They come to us like this, and we see that the animal had actually survived this injury, and this is not the first one we have seen for beavers. So what happened is this beaver, was shot here and then actually survived the injury, and its bone grew around it. The beaver skull is super dense. We see that with other animals, like alligators too, have super dense skulls that sometimes bullets do not penetrate. So alligators often survive these gunshot wounds as well. But the beaver survived. This is evidenced by the smoothness around the bones, the healing, and then that foreign object is actually starting to be encased within the bone. So this animal survived their injury. Again, that's an example of a trauma. Now we have a couple other skulls here that are actually related to each other. These are both carnivores. We have skunk skulls here and fisher skulls here. These are our small carnivorous mammals. Here we have on both examples one skull that's undamaged. So this is what it should look like. This is a fisher skull. Then we have a skull here, another fisher, that's been damaged or has an example of a pathology. And you can see that pathology on the top of the skull. The skunk was also affected by the same pathology. So on the skunk, it looks like this. Here's the healthy one, and here's the one where something happened to. So you can see on both animals, which are related again to each other, it affected them in a similar area, which was their sinus cavity or their nasal cavity. So what do you think happened to them? They were actually both affected by a parasite. And this specific parasite likes to target mustelids and mephidids. So they are typically targeting our small carnivorous mammals. So this parasite actually travels up through the food chain until it gets to their ultimate host. So we know that parasites, they always need a host to be able to survive. Most people are familiar with tapeworms or fleas. Those are examples of parasites. So we know that tapeworms affect humans. They like to live in the digestive system, and that's because they basically just get a whole supply of food to them. They can grow longer and they can spread, which is what a parasite wants to do. This parasite likes to live in the nasal or sinus cavity. Some parasites are harmless to us. Some parasites are very harmful. This represents a harmful parasite to the animal. A harmless parasite would be like the parasites that are living on our eyelashes right now, eating our dead skin cells. So I have them, you have them, every human has them. They're not bothered, we're not bothered by them, but they live on our eyelashes. So this one is the opposite of that. This is a harmful parasite. The way that it actually gets into the animal's body is this parasite is in the soil. The animals that live in the soil, like slugs and snails, they get this parasite, so it's in their bodies. Those slugs and snails are then eaten by small carnivorous mammals like little shrews. The shrews are then eaten by these animals, skunks and fishers. So this parasite actually travels through the soil, up through the food chain, and has what we call an intermediate host, being that first small mammal, that shrew. Then ultimately the parasite gets to the fisher or the skunk, where the parasite is ingested. So it goes down and then travels back up to the area it likes to make its home, which is the sinus or nasal cavity. So we can see from this example that parasites are very specialized, and This one just likes this area, but some parasites, again, like the digestive system, like tapeworms, some parasites only live in the lungs or the eyes. So they're very specialized. These animals were affected by the parasites, and you can see the bone is trying to heal over the areas that the worms are actually coming out of. Some research has shown that male populations of these animals are more affected, but scientists are still trying to figure out, is that simply because males are eating more and thus ingesting more parasites, or is there something about the differences in the sex between male and female that makes males more susceptible to these infections? Now, the last item we have here is this skull. This is a skull of a domestic dog, and nothing's actually wrong with it. It's just what a pug skull looks like. They're known as a brachycephalic animal, which means that they have a very shortened snout. But this was my little example one on the table of, it looks like there's something majorly wrong with it. And sometimes these animals are prone to a lot of medical conditions, but this is really what a pug skull looks like. I'm Ashley with Skeleton's Museum of Osteology, and this has been Skull Talk.